All right. So the general idea here, I was working with Trent the other day, and I was kind of demonstrating some of the steps that you use to look at a particular exploit, or I suppose you could also do it with malware. This is basically a technique for doing some sort of dynamic analysis and getting an idea of what it's doing over the network. Um, so this particular wiki page, it's on our public wiki. Use your favorite search engine. If you search for Tapioca Wildcard, you'll come across it. It's publicly available. I did not do a blog post about it, mostly because there's a lot of information here, and it seems like reproducing that is not necessarily the best use of the time. A little bit of background about Tapioca. It's basically an application that you can install on any Linux system, and it provides you a wireless access point that you can use for network testing. So if you have an app on your phone and you want to see what it's talking to over the network, it'll go through Tapioca. That's all been documented, and it's in the wiki. The idea for this particular way of using Tapioca was let's say you're running an application, not necessarily an exploit or malware. It could just be legitimate software. And you want to know what it's doing on the network. I assume that's probably, I know back in the past, like with the malware analysis folks, like there was like the Anexa toolkit where I think it maybe implemented something similar to this. But the general idea was you run something dynamically in a virtual machine that's short-lived, and then you're observing what it's doing on the network. So the very first way that I ended up doing this was years ago when we created our exploit catalog, XCAT. The way that it implemented this was it created a wildcard DNS server, which meant I could do like nslookup google.com, and it reports the IP address of the web server. So basically anything that gets looked up by DNS name, it will resolve to that particular host. Where I realized that was a problem is I ran an exploit, and it tried to download its second stage by IP address. So what I wanted was a machine that's providing internet connectivity that will not only resolve or answer any DNS lookup as this is me, but it will also answer to every single IP address. So if something tries to connect to 1.1.1.1, it'll connect to that. So the general idea is you will have a system where everything resolves to the server that you're working with. And I'm going to go to the whiteboard just real quickly. I don't really have it. It's probably in the wiki page there. But the scenario here is I have a test VM, and that could be Windows, Linux, whatever. This machine's upstream internet connectivity will be provided by my wildcard Tapioca. So what that means now, generally when you're setting up wildcard Tapioca, this will have a connection to the actual internet, but we basically unplug that just for belt and suspenders. If I'm running something in this machine that I don't trust, I don't want to have it connected to the internet because I have no idea what it's going to do. It could, initiate a DDoS. It could initiate a DOS attack. It could connect to other systems on my network. Like if I'm running this test VM on my machine that's on the Mantis network, if I run malware in that, it could presumably connect to anything else on my own internal network and do very bad things. So the idea for generally looking at software you don't trust is you just run with a disconnected network. Not connected to the internet means you're not going to be able to do anything bad. The problem is, if I'm running an exploit in here that tries to do something on the network, and I have a disconnected network, I'll never see anything happen. I won't know that it attempted to download something. I won't know that it did an NS lookup or a DNS lookup or anything like that. So the idea here is we create our own little isolated environment. And the way that you do this is if you use VMware, you'll do something like, I think they call it VMnet. Basically, you pick a number, and all of the machines that are on that particular VMnet will talk to each other, and they won't be able to talk to anything else. So in this particular case, I use VMnet 15. I think they give you like 1 through 20. You can pick whatever you want. So that's the back information. If CERT Tapioca is on GitHub, you basically run the installer on a Linux machine, and it converts the machine into a Tapioca station. This is a step above and beyond Tapioca in that it will set up the wildcard DNS and IP address. So I'll give you a switch over to my virtual machines here, and I'll give you a quick view as to how this is set up. I think this has already been capturing some stuff. You just hit the D key and it'll delete things. So just to kind of, on the VMware side of things, to explain like what I just kind of did on the whiteboard there, I can see that this particular machine has 2 different network adapters. One of them is an upstream adapter. I have that disconnected just for extra security. The routing tables internal to this machine don't route the traffic, so even if that were connected, it's not going to get out to the internet because everything resolves to the local host. But then basically I have a machine here that's configured to use VMnet 15. So let's say I have a machine that I want to test something in. In this particular case, there was a VBScript exploit that I ended up getting a copy of, I think through VirusTotal.
So this VM is connected to the VMware Net 15 as well.
Yeah, so I'm just going to scroll this up off the screen so you can see. So that's on VMnet 15. So before I actually get into any opening up of any exploits, we'll just do some tests from our command prompt, right? So if I want to do ping cert.org, oh cool, it pings. It's 10.0.0.1. If I want to ping google.com, same thing. That capability I had all the way along. It's very easy to set up a DNS server that answers. You know, you just add an entry for star or dot or whatever, and it'll answer to everything. But this is the part that I think is what made this become a little bit interesting. Was one of the things that makes it do an IP wildcard. So if I do ping like 11111, it answers. Ping 8888. Those all answer. So I have a machine right now that believes it's connected to the internet. It can resolve things if I want to.
Even like random generated domain names, like the crazy ones are fine. Like
yeah, let's try something. Let's go to. It probably doesn't exist, but let's see. Internet Explorer comes up. I don't know why it's so slow. Too many VMs running, I suppose. Give me a break. All right. So everything resolves to the server that lives on this wildcard server. Oh, RDB, I swear to God. Sorry. This particular wildcard machine has a built-in copy of the XCAT web server. It's really just a brain-dead sort of PHP front end to like a directory structure. I wrote it like 14 years ago, so like nobody look at the code, but it basically is like a place where we put exploits, right? So I'll go back here, and I'm pretty convinced that I now have a machine that is connected through this wildcard machine, and it thinks everything is fine. Apologize for the lagginess. I don't know if it's a Wi-Fi thing or whatever. So back to what our original goal is here. I have an exploit. If I think this is an actual doc, or it might be an RTF possibly. Oh, this lag is killing me. Let's just look at it in Notepad and see what it's doing. If it's a docx file or some sort of modern Office document, it will be a zip file and you won't see anything useful. This actually happens to be an RTF. I'm not sure how people here on parsing RTF with their eyeballs, but I don't know what this does. But it doesn't matter because I have a machine that can't get to the internet. So what I could try doing is opening it. Now, since I opened this with Notepad, it wants to associate that. But I think what I can do is I'll just say open this with Word 2016. Now, quite often when you open up an exploit, it'll try to do something against the internet. And I can look here and I can see in my Wildcard VM here, it tries to get autosoundcheckers.com/s2/search.php who equals 7. Now, if you notice, this is a little sort of behavior that I see often in Office and some other Microsoft tools, is that it actually warns you and it says, hey, this contains links that may refer to other files. Do you actually want to update this document with the data from the linked files? You notice that I didn't answer that yet, but it has already tried to retrieve this file, and it's a 404.
Is it a 404 because your server, like...
My server doesn't have it.
Right.
But at this point in time, I now know what it's trying to do. So what I can do is on this local machine, I can put a file there that will be that file. So this is one of the things that I brought up in like some of the chat rooms before, is when people capture an exploit, they will get that first document. So like in this particular case, when the VB script exploit was being talked about, they're like, hey, this is the hash of the exploit, and this is what people need to worry about. The problem is this RTF document, it just retrieves a remote document. That's it. The exploit is not in this document. There's nothing dangerous about this document at all. All it does is it has an IE COM object built into it that tries to render this remote content. So the goal is basically to find every piece that's involved in the exploit. So at some point in time, I remember asking for a particular hash. I think I found, just through some creative Googling, you can end up finding hashes. Somebody wrote this up and they said, hey, the hash for this is this particular thing. And we didn't actually find it, but eventually we found one of these documents. So what I ended up doing is, and I do this just as like a little bit of a convenience factor here, is this Wildcard virtual machine has a shared folder with my host machine. So if I go to my Wildcard directory, I can see I've got a directory structure here that will actually appear in my web root. If I look at all these different folders here, these all exist on my host. It's just kind of a convenience factor for me. I'm generally not dealing with actual malware where it's going to be doing like things that I definitely don't trust. If that's the case, then I would avoid having VMware tools installed on the machine because that increases your attack surface. Those sorts of things can be exploited. But I created a directory in here called VB script. And I ended up finding this particular second stage that it tries to download. So if I look at this particular file, this is a file I got off of VirusTotal. So this is the thing that is the actual exploit. The first RTF document just retrieves it. It doesn't do anything. But what it'll do is it will try to render this. And I can look here, and I can see they've got some obfuscation in here. We've got some capital I's and some L's just to confuse your eyeballs. We've got some unescapes. We got a bunch of nonsense in there. And I've got a file. Now, I can see right here, this is going to be my shellcode. If I ever see a large block of %u escaped bytes, this is a way that you can get from like VB script or JavaScript. You can get like any arbitrary byte value and encode it into a string. So what I can do here is I can now present my testing environment to like just have this file available. So rather than a 404, have that file there. So if I look at my web root, I'm just going to say make directory S2. right? Because if I look at the file it's requesting is s2/search.php. And then I'll do copy this directory in here, or copy the file. And what was it? 8 something. And I just want to call it search.php. So now I've configured my fake internet host as like more closely reflecting what this exploit is working for. So what I could try doing is I'll just try opening up this exploit again. And what ideally should happen is it'll now request this auto sound checker /s2/search.php file, and it'll be there. What it does, I don't know. But again, I don't really care because it's isolated. It's not connected to the internet in any way at all. So I can see right here, this actually, if I look at, and this is just MITM proxy that Tapioca is using, but I can see right here, in auto sound checkers, I can see the request for it. I can see that the response is this particular file that I just put in here. And I can see the very next thing that it does is it actually tries to download a WLL file. That's a Microsoft Word add-on. If I place a Word add-on in a particular directory on a Windows system, the next time I launch Word, it'll run the code, right? So I have a pretty good idea here that I've probably already run shellcode. I think that I've now demonstrated, that, and I can see that this is hung up because it didn't actually do anything. So I'm going to revert this. I highly recommend using snapshots. Disk space is very cheap, especially when you're looking at reproducing exploits and stuff like that. You want to know in good state. So let's go back to our wildcard directory, and I'm going to look. Let's go to my VB script directory, and I'll open this on my host just because it's a little bit easier to work with these files here. What this stuff is doing, it's not immediately clear. I see a lot of obfuscation, but what I can see is if my screen eventually scrolls. Eventually the screen will scroll and I'll see a good chunk of %u escaped code, right? What I can actually do is I can replace that shellcode with something that I know what it does. The very easiest thing that you can do is replace the shellcode with CC bytes. And CC bytes are decoded as an int3, which basically is like a debug interrupt. If you have a debugger attached, or if you have it set up for just-in-time debugging, if you ever execute a CC instruction, it'll just trap to the debugger, and you'll be able to see what's going on. What I'm going to try doing here, let's give it a shot. I'll try it with the CC, right? Right. Gotta be an admin. Oops. First thing that I'll do is I will set up my WinDebug to be a just-in-time debugger. WinDebug capital I. So what that means is if Windows apps encounter a crash, WinDebug might just kick in and I'll be able to see what's going on. Now, I'll just delete this stuff, and you can see you'll get like stray requests, like a Windows machine just being turned on. It's going to do stuff. It's going to make requests and everything. What I'm going to try doing here is I'll go back into my S2 directory, and then I'll copy my main VB script. Oh, God. I love laggy turn-ons. VB script. I have a file here called cc virus total, and I'll copy that to search.php. So if I look at this particular file, I can see I've got all the stuff in there. Eventually, when it gets to the point of executing the shellcode, let's see, oops. I don't know if I did it in caps or not. Right. Basically, all I did is I took that entire block of shellcode and I replaced it with this. I basically got 4 bytes of CC instructions. The reason you want more than at least 2 is based on like byte alignment of the instruction you land on. Like, you want to throw some extra ones in there. So let's give it a shot. I actually kind of forget if this actually does trap to a debugger or not, but if it does trap to a debugger, we now have showed that we can control the execution and check that out. Again, I apologize for the lagginess here. And I can see I'm on the second of my 4 CC instructions. If I want to step through these, I can see, is it actually executing it? And sure enough, I've now got code execution. So what this means is I've now got an exploit that I've sanitized that doesn't do anything really interesting other than pop up a debugger. But at this point, what this means is I can replace that shell code with whatever I want. I can take some stuff out of Metasploit, perhaps. So I'll actually do that. I already did this ahead of time. It's basically you just find the bytes in the file, replace it with the shellcode that you want.
Does the size of the bytes in the Windows file matter?
In this particular case, it does not matter because it's a VB script file and the length of it doesn't matter. If you're ever dealing with a binary file, sometimes if you replace something with something that's a different length, you'll break it. So if I take a PDF document and I replace like a chunk of that with something that's larger, it'll break the PDF because at the end of the PDF, there is a table of contents that shows you the offsets. And if those no longer map up to anything, it's just like, hey, this is no longer valid. In this particular case, it's plain text. It's very easy to replace the shellcode with whatever you want it to be. I have a thing called Metasploit calc VB script, and I'll copy that to search.php, right? Metasploit includes the way to generate shellcode, and you can have it encoded in the right way. But the general idea here is, my goal is, I've now reproduced this problem. This snapshot was a virtual machine that was fully patched at the time. So like one of the things that you're interested as somebody that's analyzing a vulnerability is this something that affects a fully patched system? And there I go. One of the things that you would like to analyze as a vulnerability analyst is like, is this a reliable exploit or not? Now, in this particular case, I'm getting prompts saying like, hey, it crashed last time, but automatic updates? No, screw you. What I'll do is just revert back to my snapshot. But I'm pretty confident that in my couple attempts of opening this particular document, I now have code execution that's reliable. So I'll try this one more time. Again, waiting for the little bit of lagginess. But if I see calc.exe pop up, I now know that I have a reliable exploit. And when you have a reliable exploit, that's a very bad situation. If I have a fully patched system and my exploit is reliable, the attackers jump on it. There's certain types of exploits that rely on a certain amount of luck based on like heap layout and other things like that. In this particular case, it works every time. I didn't actually analyze the exploit. If I look at this particular file, if I wanted to, I could maybe, if it was my duty to figure out what is the underlying problem here, I might look at it and figure out, can I get a minimum test case? The particular attacker here is just trying to be a little bit annoying by just not really naming anything useful. But I've gone as far as, and when I can actually see the shellcode here, This was the particular block, and I basically just generated the Metasploit. In Metasploit, you can say like win32 exec calc.exe, and it'll do that. So I basically have achieved my goal of figuring out what does this document do by using the Wildcard Tapioca virtual machine. I can see, okay, it's now making a request for this search.php file, and I can actually like test out how reliable this is. One of the other things that's interesting, and I'll get into in one of the cases that I look at, there's two more cases that I'll look at. One of the things that we like to do when we publish a vulnerability note is we provide guidance as for how people can protect themselves. So imagine this is a case where the software is not patched and the exploit is out there and it works. What do I do? This is where tools like Emmet and Windows Defender Exploit Guard come into play. If I do something that forces ASLR, like maybe that can help the exploit to break. If I can do things like stack pivot detection, all these things that are built into Emmet and Windows Defender Exploit Guard, if we can show that that stops the exploit from functioning, then we now have guidance that we can give people when we publish a vul note. It's not just panic, stay off the internet. Nobody's going to do that. If we can give people valid guidance for what do you do to protect yourself, that's a huge win for us. Any questions so far before I go to my other exploit?
You're saying it's actually now these Windows protections protected against this.
None of the Windows protections built in. So what happens is Windows is like decent at protecting itself out of the box. The problem is it's not good enough, which is why everyone that cares about keeping their computer safe is running Emmet, or if you're running the latest version of Windows 10, you're using Windows Defender Exploit Guard. That allows you to implement protections above and beyond what the default baseline is. Microsoft is a little bit safe with their defaults in that they don't want to like break old software. This is the thing that comes back to get them all the time. It's like, I want to keep backwards compatibility with that one prior app, which needs backwards compatibility with something else. And like you can have a Windows 10 system right now, and it has like Windows 3.x legacy cruft in it. They've done a pretty good job of cleaning out a lot. But Microsoft is in a situation where they don't want to push out an update that breaks things that people rely on. So the general idea with any Windows system is it comes like it's okay out of the box. I would never use a Windows system out of the box like on the internet. Like you're in big trouble if you're doing that. That's why you do things like Windows Defender Exploit Guard. That's why you do Emmet. You do things that help to break exploits. So this was the VB script exploit. It's a very good one because it's quite reliable. I forget off the top of my head like which Windows Defender Exploit Guard protections protect you. There are certain Emmet and Windows Defender Exploit Guard have certain like shellcode breaking heuristics. If they detect that your stack pivots unexpectedly, it'll just kick in and say, hey, like this is something that shouldn't happen. So one of the other things that we ran into was this is just another exploit, right? And the idea is people on Twitter will talk about an exploit and they'll say, hey, this is an ODE, and they'll often list a hash, or they will list a link to VirusTotal. If you'll notice that a lot of the some of the file names here, I have a .VirusTotal extension to them. I've got like a Python. If you have an account on VirusTotal, you can download any of the things that they have listed there. I know that floating around the malware team is like a Python script that leverages at least somebody's API key to download stuff. So in this particular case, my starting point is I found a hash, I want that hash. And that's why that question often, like, I might ask people on the malware team, I might ask, hey, has anybody seen this hash? And they've got piles of stuff that they can look at. But quite often, like the hash that I'm looking for is an exploit here. So let's look at another one. And you can see here, like this is just Windows background noise. What's kind of interesting here is like it's getting something from Windows Update, but it's getting it over HTTP. Like I don't like that, but if it is indeed validating the signatures of the files it's downloading. I guess it's not terrible, but it's still bad. All these are 404s because these aren't files that exist on this local system. The Tapioca machine is really just like a wildcard DNS, wildcard IP. It's got Apache and PHP in it. So if I look at my like kind of standardized web root directory, if I go up a directory here, this is really just files that xcat is, index.php, and it's really just the thing that gives you a directory listing. It's horribly insecure, but I don't care. I'm not distributing the software, and it's only used internally. That's what everybody says when they write bad software. It's like, it's only for me, and then like eventually it ends up on GitHub, and people rely on it. So let's try this Excel spreadsheet. And this is another case where I got an XLS file. I open it. Now, consider the case before the Wildcard Tapioca machine. If I were to open this document in a machine that doesn't have network connectivity, it opens up and nothing happens. If I don't have a valid Ethernet network connection, it's not going to look up an IP address. It's not going to look up a domain name. It's not going to try to do a GET. But because I'm running this machine through Tapioca, I can see right here, this is trying to download people.dohabait.com/song/whatever. And that's not found. This is another case where there is nothing inherently malicious about this Excel spreadsheet. Now, if I were to upload this from Virus, or look at the status of it on VirusTotal, it'll probably tell me that it is indeed malicious, which is kind of an interesting scenario in that there's nothing inherently, like, there's no exploit built into this. All this is something that will download and parse something from the internet. And if you run it through Tapioca, you can get some insight.
Yeah, but if your doorman lets all the vampires in the building, I think you can fire the doorman.
So you're describing Olay. So Olay in Microsoft Office allows you to download anything from the internet, and render it.
If what I'm saying is, if it loads from a known bad.
Okay, right.
If it loads from a known bad URL,
right. So that's fair.
Call it
right.
malicious.
So it
Even
is
if the
right.
document itself could have just loaded any arbitrary URL.
Right. Absolutely. And so it is absolutely correct that VirusTotal lists that document as malicious. The problem is if you start thinking about, well, let's start cataloging exploits. That Excel spreadsheet is not an exploit. There's nothing about it that triggers a vulnerability. So something that we need to keep in mind is if our goal is to collect exploits, we need to make sure that, it's not just this hash that we got off of VirusTotal, but it is the thing that it gets that might actually do the thing that is malicious.
We're a few hops away from having that problem yet, but yeah.
So I'm gonna go to like the updated. I think this is I think this is the current version of Flash. This is one that Flash was released, I think, the day before or the day of that I got this exploit. And I saw a behavior here that was kind of interesting. But let's just try it. Oh wait, where's my knock? Maybe it's off screen. Yeah. And I think the first time around, I called it a .doc file, which will not open. So let's call it .xlsx. Delete this just so I get to a clean slate. Yeah, right. Windows is always doing stuff.
Have you ever just put something running, let's see how much Windows sits there, and how much
it does a lot. And if it's Windows 10, it's very chatty.
What happens if you doesn't have internet connection?
It won't.
Do
if it doesn't, if you have a machine that doesn't have internet connectivity, do you mean
what are those requests doing that are impactful to the system? I guess is right? Something like that, I guess.
A lot of them are telemetry, like Windows. Microsoft collects statistics about like things that you search for in the start menu, and they collect information like how fast your computer is and how many apps you have installed and
You can't opt out of that.
what's your social security number. No. There are ways that you can turn off a lot of them, but like it is a list of like 15 steps, and it involves like specific firewall rules. And like, if you're running Windows 10, like every time you click on this search button here, like that pings home to Microsoft. The instant I click on it, it sends a request to Microsoft. And this is something that you can discover by using this wildcard. So let me go back again, and this is a patched version of Flash. I'm going to try opening up my XLS file. Now, this is interesting. I see a new dialog. Warning, this document contains embedded content that may be harmful to your computer. Do you want to allow it to play or not allow it to play? Now, the interesting thing is, if I were to scroll this down, geez, all this Office stuff. Let's see if I can find it. See that? It's already attempted to retrieve this remote document before you answer this prompt. This is an odd behavior that I see very frequently. And it's like, they give you a prompt, which gives you the idea that like, I'm in control. I'm the one that can like tell it to not do stuff before it does it. Now, an interesting thing that I noticed here also is like, where does that prompt come from? I don't know exactly for sure because I didn't really get into the code that's doing it, but Process Explorer. Anyway, if anybody has a Windows machine that they're analyzing anything on, make sure you install the sysinternal suite, put it somewhere in the path. Between Process Monitor, Process Explorer, it's hard to analyze anything without it. If I look at the Excel binary here, I can see it has already loaded the Flash runtime. It turns out that particular warning dialog is in Flash. So I've opened an Excel spreadsheet. It has loaded Flash. It has parsed something. It is code in Flash is at least executed to the point that it's displaying a prompt to me. So even just by opening this document, it's loaded Flash and it's running stuff. And I think what it's doing is the folks at Adobe have said, well, if you have a Flash movie, inside of this Excel spreadsheet is a Flash movie. And the reason it's loaded the Flash runtime is because it's already parsed that Flash movie. So just by opening a document, I've now parsed a Flash movie, which could have triggered a vault in and of itself. I think the folks at Adobe have said, well, if I'm ever running a Flash movie that references a remote Flash movie, that's probably bad. So I'm going to display this prompt to the user. In this particular case, I've never found this particular Flash movie. I don't know what I either don't know what the hash is, or the hash never came up in VirusTotal at the time that I was looking at it. So I actually never was able to actually confirm that this Flash exploit works. But I can at least test the behavior. What does Office do? What does the Flash runtime do? If I'm testing like attack surface reduction, I can test like disabling Flash so that it doesn't play. So I can actually, even though I don't have the code that triggers the vulnerability, I now know what the containing document, I don't know if you want to call it a dropper, but the document that triggers the thing that would trigger the exploit. I have enough like contextual information to kind of give a little bit of guidance, because right now I can tell between the prior version 29 of Flash, it would execute that content without prompting me. And I can now see, as of this new version of Flash that was released that same day as the exploit, I now have a new prompt.
But you said, based on your analysis, it's already executed. It's already parsed it. Right?
It has already parsed the local Flash content.
Oh, okay.
Now, here's where attackers get tricky, and I think this is where they're trying to protect their tradecraft. If I have an Excel spreadsheet that contains an exploit inside of it, and I email that out to a bunch of people. Now all the analysts have the exploit. I think the people that are writing the exploits are counting on the scenario that we're in right now where I never found the exploit. I never got a copy of the Flash movie. Even though I have the document that loads the Flash movie, I never got a copy of the Flash that triggers the vulnerability. And I think it's one of these things where this is the reason why exploits frequently aren't self-contained, but the exploits leverage something that they can download dynamically. And if they want to, at the point that the attacker knows that their cover is blown, I can just pull that, I can remove that file from the remote server, and now I'm minimizing the chance that somebody can analyze the exploit.
More important, it also lets the attacker decide, have control over distribution of the exploit. So if I send this out to the mailing list that I know covers the company I want, and I know what their IP range is.
Oh yeah.
But I know there's also a whole bunch of people that I don't want to hit either.
Yep.
I set my web server up so that it hands back 404s for everybody except
Absolutely.
the IP block, and that IP block gets the exploit. So
Yep.
even if you're collecting these things and you're
Yep.
scanning for them, you may never see the exploit just because the server, not because it's not on the server, because
Yep.
the server's configured to not give it to you.
So the attacker, it's multiple benefits for the attacker. They can control who they actually deliver the exploit to. When their exploit gets burned, if they have another exploit in their pile, they can just replace it. And this actual dropper Excel spreadsheet still works. That allows me to get an exploit that lives forever because all it does is it retrieves something remotely and then it does something with it. The other thing that I'm looking at the request, this is the HTTP request for this particular Flash file. I can see that, oops, sorry, that's the response. If I go to the request for it, I can see that I have a user agent. I potentially have a cookie. And these are other ways that attackers are preventing people that are analysts from getting and analyzing the stuff. If I run wget on that file, it uses by default the wget user agent. And as an attacker, I'm going to set up a web server that gives a 404 for anything that's wget. There's no reason for an actual victim to be using wget. If you have wget as your user agent, that's something that tells people hey. And that's why when I do use wget, I have an alias that just sets an actual valid user agent so that it emulates as close as possible. Now, if it's doing tricky things with cookies, then it gets a little bit trickier. So this is another case where Tapioca Wildcard is pretty useful.
Does it matter which one of those have you?
If I click on one of these?
Yeah. Does it?
If I allow it to play, well, let's try it. Let's go back here and let me just hit the D key and just delete all my stuff.
So
To see if it makes a request.
Your special wget and try to get that file.
It doesn't exist. It didn't exist at the time that I was analyzing it, and I couldn't find either. I forget at the time. It was a month or so ago.
Attackers out, I pull my exploit.
Right. Now the thing about this right here is this is already This has already made the request for the remote Flash file, so I think it doesn't matter which I click because it's already made the request.
Right.
Right? So if I say allow it to play, it'll probably just be all right, well, it was a 404, so it's just nothing. So really didn't do anything interesting. Process Explorer can give you a little bit of insight into what's going on. So these are just two examples. These are both Microsoft Office. You get an exploit, and if you analyze it in an environment, these steps, that's fine, but it takes time, right? So I've already built a VM. If somebody wants their own VM, I can happily point you in the right direction. The idea with this VM is you need your own local instance of it. I could have one, so I've got Fusion on my host here. I could have my own. You can do this very same thing with Fusion. I think it requires Fusion Pro or a version that allows you to set up the virtual networks. But the same idea is you have your machine that you're analyzing your code in, and its uplink internet connection is this Wildcard VM, and it basically just kind of emulates what it is to be on the internet.